Hey class, how are you doing? This is our video for our very first lab, our power lab. The test that we're running in this lab is the Margarita-Coleman stair climb test. So let's go ahead and get into this. I'm going to explain what you are going to need to turn in, a little bit of background on the test, the equipment you're going to need, the procedures, and all of the different mathematical facets that you're going to need to do in order to complete this lab efficiently and correctly. So first off, what you'll need to do is be sure to film or record on your phone a short video of either you or your friend or whoever you're having run this test. You need to record them running it at least one time and submit that so I can assess if you're running the test correctly. You'll see later on that we're going to do multiple trials of this test. You don't need to record every trial, you only need to record one trial. So I'm not expecting these videos to last much longer than 20 seconds maybe, because the test really only lasts a few seconds. Next thing that you're going to need to turn in, you can just turn in this entire document, or you can delete some of it, these background procedures, all of those types of things. You don't need to turn those in. But the worksheet kind of at the back end of this document, that's what you're going to need to turn in. And in fact, it says what you turn in for lab 1. So all of this, it's going to be filled out, of course, correctly, hopefully, and that's what you're going to end up turning in. So let's go and get into this. I want you to read all of this word for word. I'm not going to read it all exactly to you, because I don't want this video to take forever. I want to get down to the parts that you really need to see done and everything like that. So, the background, this is the Margarita-Coleman stair climb test. It's used to assess like leg power and muscle activation of effectively the shortest term energy system that we have, the phosphocreatine system. That's what PC stands for. It's also frequently called the phosphagen system. So it's really just how much power an individual's legs can produce in a very short period of time. There's a few other words in here that you may have not seen before. Anaerobic, I think everyone's seen that. That just means without oxygen. Alactic. That just means that your body is not going to be producing lactic acid, which is the byproduct at the end of, the 10-step glycolysis. So we shouldn't be feeling any burning sensation in our legs from doing this. So this test, what you're going to need: a flight of stairs. That's probably the most important part. And the flight of stairs, what you're going to need with this flight of stairs, it needs to be at least 9 steps high. And each one of the steps typically is going to be somewhere between 6 and 8 inches or so in vertical displacement. And also, important note on these steps is that you're going to need about 20 feet or 6 meters of a flat surface in front of these stairs, and that's because we're going to do something that is frequently called a fly-in. So from about 20 feet away, the individual will start running, and then once they get to the stairs, they're going to bound up or jump up them 3 steps at a time, and you're going to measure once their foot touches the 3rd step. That's when your stopwatch is going to begin, and then the stopwatch is going to end whenever their foot touches the 9th step. So really, it's just going to be really quick, just a few bounds, and then they're there. Now with this, you're going to have to measure the vertical height between the 3rd and 9th steps. So we aren't worrying about horizontal displacement, only vertical displacement. So whenever we talk about the height of the steps, that's all we're going to be measuring. We're not going to be measuring like the hypotenuse of the right angle or any of that nonsense. Only adding up the steps. So you can just measure one step, assume that they're all the same height, and then just multiply it by however many steps there are that they're actually going up. And notice here, it's saying 3rd to 9th, and it's okay if it's more than that. It just needs to be at least this. It can be third step to the 12th step. It can be, well, if you want to get super weird, you can go fourth step to the 23rd step or something like that. But just typically it is done as third to ninth step. Other things you're going to need is a tape measure or a ruler, something of that sort. Also a stopwatch, and most of us, we have stopwatches on our phones and things like that. And marking tape. Now, this is just to measure the beginning, the 20 feet away from the beginning of the stairs, where the third step is, where, every three steps up is, so that the individual running up them can visually see like where they need to throw their feet, and then where the very last step is. And it doesn't need to be marking tape. You can put rocks on there. It doesn't really matter. So let's go and look at this procedure and test protocol, all of these types of things. So allow yourself or whoever you're working with to warm up for a little bit and to have quite a few practice runs at this, because one thing that I've noticed just about every time that I do this test is that individuals have a really hard time 3 steps at a time. Most people can do 2 steps at a time, but 3 steps is quite difficult for most individuals. And honestly, it doesn't need to be 3 steps at a time. Just if you're taking 2 steps at a time or 1 step at a time, it's going to severely increase the length of time that it takes you to ascend all of these stair steps. So it's just generally recommended 3 steps at a time. So if you do have a question of can we do 4 or 5 steps at a time, if you can jump all 9 steps at once, that would be great. But you need to practice it, because I've had numerous individuals roll their ankle or slip and fall. So if you're a bit clumsy, please be careful with all of this. So we're going to need to measure the individual's weight. We need it in kilograms because we need SI units for all of this type of stuff. If you have a typical weighing scale that gets them in pounds, just convert that to kilograms, which is just pounds divided by 2.2046. That's at least how I like to do it. 2.2 is okay. And then after you get that, allow them to warm up, do some jumping jacks. The reason I'm saying that is they need to do some type of plyometric thing to start getting ready for what they're about to do, jumping, or bounding if we're being a little bit more accurate there. And after that warm up, explain to them and or to yourself that you need to run up these as quickly as you possibly can. We're going to be measuring this to the nearest tenth, hundredth of a second, so that's how many decimal points that we need to go. And whenever you're turning these things in, typically I think it's fine if you just go to the tenths place, because with your hand, depending on how quick your reaction time is, I don't think we can get much more accurate than that. Okay, so measure their weight, then have the client 20 feet away start running in, and then as they reach the stairs, once their first foot touches on the third step, that's when the stopwatch begins. And once their last foot hits the ninth step, or whatever the end is, that's when the stopwatch ends. That's when you hit stop on the stopwatch. You can have multiple people doing this and so on and so forth, but depending on how many friends you have, how many people you want to get involved in this, you can do this all on your own. Allow for 3 trials, and we're actually going to measure all 3 of these trials, and big point right here, have 2 or 3 minutes recovery between attempts. One of the big reasons for that is since we're testing the phosphagen or ATP-PC system, it typically takes your body approximately 3 minutes. It can be closer to 2 minutes if you're highly trained in this, but typically around 3 minutes to resynthesize all of the phosphocreatine so that we can have optimal or peak power output between all of these. Now, the formulas that we're going to be using is this here. Power, it's equal to body weight multiplied by 9.81. I'm going to do 9.81 multiplied by the height, and that needs to be in meters. And that's the height of the stair steps, and then you divide all of that by the time. So here, if we're looking at this pictorially, this is just about the easiest way to really understand how all of this is going. So notice here, 6 meters. You're going to start at point A, and well, it would be cool if it had, a point B, point C, all of that type of stuff, but I think you understand it. So start 6 meters away, we do a fly-in, and then once their first foot hits that third step, that's when the stopwatch begins, and then once it hits the ninth step, or whatever the end is for you, that's whenever the stopwatch ends, and measure it as accurately as your stopwatch will allow. And from all of this arithmetic, we derive these standards. So the stair sprint standards, these are all expressed in watts, and I'm going to show you how to calculate all of these things. And we have different age categories, so on and so forth. For males and females, depending on sex, it's slightly different what the standards actually are. So, all right, here, let's look at what you're going to turn in. So maybe what I would do is go ahead and pause the video and go out, run the test, make sure that you're getting their body weight, the height of all of the stairs combined, and get the amount of time that it takes on these 3 trials. And then after that, I might come back to this video and look at all the mathematics that we're going to do. So I guess I don't really need to pause because you can pause it. All right, so with this, here's just about going to be the easiest way for you to do all of this, is if you take all of this and you put this into an Excel file. At least this is what I like to do for making sense of things. So let's take myself, for example of this, how all of this could work. So here, I weigh about 170 pounds, right? I am, let's say I'm 42, which I'm not 42, but who knows? This video might still be running in those years. Sex, male. My sex isn't mass. Come on. Okay. So first thing that you're going to need to do equals, divide that by 2.2046. Hopefully that makes sense right there. And something that you could do if you want, if you need to hone in right here at this B1, you could do this. If you put a money sign in between that letter, that means that we're going to drag it down just like that, and it stays constant. Now, if I don't do that, I know this is an Excel class, but just for those of you who want to know, see, if I don't do that, that's what it ends up being, because it goes to the next things or whatever, right? Or you could just, oh man, that's not what I wanted to do. So you could just copy it and then paste value if you want to do that, right? So you can certainly do that. And then here with this gravity, 9.81. You can do the 0.07, but I don't want to. And notice that's the acceleration due to gravity, of course. And here with this height, let's go back to this. Let's just assume that it's 1.05. Well, no, I won't do it that way. Let's see how you all would actually do it. So let's have it be to where each step is 6 inches, and there are 10 steps or so. steps that we're doing. So you don't have to do it this way, but this is typically how I do it. So this, it being 6 inches, how you I would typically convert this to centimeters, which you would multiply by 2.54, and then, centi means 100 divided by 100, and then uh, 0.05, zero point 0.15, sorry, and then have that multiplied by 10, and it would be about 1.5 meters or so. And then I'm just going to paste the value into all of these things because really their weight should stay the same. Gravity should always stay the same unless, I don't know, you go to a different planet. Height, that should stay the same unless for whatever reason you want to go to the 9th step on one, the 10th step on another. I don't know why you would do that, but you could. This variable should be the variable that changes mostly. So, with this, let's say my first time it took me 2.01 seconds, the next time 1.75, and the last time 1.66. Why not? I'm just making up numbers. You're actually going to measure that. Now, something that you're going to need to do is measure the amount of work in joules, which with that is going to be force times distance. Now, for those of you that aren't quite aware, if we multiply mass in kilograms by 9.81, we actually get force, which is a different unit, in newtons. So in order to get this work in joules, we would multiply that multiplied by that multiplied by that. So that's however many joules in work that it is. And then over here, power, which is just going to be that number divided by the time in seconds. So you'll see that my wattage is going up. So if we look at this in order to get this classification, hold this in your head. Power 570 some odd watts, and age 42 of a male. So let's go back to this. So over here, men's classification, right here, 42 would be right, that would be poor. So this one would be poor, and did it go up to 637 or what was it? Yeah, 637. So then these next two would be fairs. That's how you read that, and hopefully that made sense by me looking at min, 40s, wattages right in about here. So we're seeing a clear warming up effect. So with that, no, not there. Here, all of that would be filled out. So you could fill out all of your stuff in here. Next thing, a line graph of the 3 trials and all of that type of stuff. How you could do that, insert. So I highlighted all of those. Hopefully that makes sense. If you don't know how to make a line graph, either contact me or YouTube it, right? So here's how this is. I almost said star test. And then we would just insert some axes. So power watt. If I knew how to spell watts, huh? And then trial. that would be how you would do that. Or you could do something like this. If you click on that and you do select data, edit trial 1, um, it's either semicolon or colon. I always forget what that is called. This is not an English class, luckily. Oop, trial 3. And then, so we could do something like that, and you would just simply copy and paste that in here, and then sometimes that happens, and then there you'd go with that. Now, with some of these questions, I want you to think relatively deeply about these. What are some common mistakes that occur during the test, or that could occur? So think about errors in the person measuring it, if you're measuring this on yourself, errors in the participant running the test, or mistakes like they don't stretch enough beforehand or warm up sufficiently so that we're really not even getting a good effect on this, because something that if you were seeing results that look relatively like this, well, maybe we need to get a trial 4 and 5 to see if this peak power output stabilizes, because we don't know, because this first one is clearly not the best, second one also not the best, third one, is that the best? Who knows? We would have to measure more to see if there's kind of a plateau effect. Some other sources of error, your reaction time and how fast your stopwatch works, maybe even the contractors that made the stairs, like are they all actually the same length or vertical displacement? What is the practicality for using this test? And this one, I want you to write about this a little bit, but here's something that a lot of individuals don't think about whenever we're measuring power, is we normally just think about this being useful for, say, football players, basketball players, athletes, so on and so forth, but it's actually really important for older individuals or just about anybody, really, because one thing you might not know is fall risk. The older we get, the more fall risk that we have. And our ability to contract our muscles very quickly, particularly our hips and quads and all of those types of muscles, you can catch yourself. Because your center of gravity falls out of your base of support, your ability to throw your leg to catch you, that's a power movement. So this test is actually would be a really good test for just about anybody. So that is about it for this test. Please turn this in, video yourself doing it, turn that in, and I will see you in the next lab. Reach out if you need any help. So good, awesome, thank you.